Yes.
So on the last one, where it's the FOTC one, right? It's the derivative of g of x equals f of x. Is it that you're not supposed to write the integral for the answer? It's just supposed to be...
So what do we know the integral is now? What's another name for the integral? Besides area. Like, derivative is slope, integral is area, but what's another name? What's the first thing you do with an integral? You try to find the what?
The antiderivative.
Beautiful. So if I take a derivative of an antiderivative, they should cancel.
So it just shouldn't be written in, is what you're saying.
Well, it's gone.
Well, if you're just rewriting the equation, right? You know, you're just essentially...
I think I remember you put an x in, right?
No, I just put the integral of 2 to x and made it negative.
But you put an x in, so you had started doing the derivative. Or...
No, because the original one has a t in it. And
exactly. Has a t in it. When do you put the x in it? After you have taken the derivative. Otherwise, it doesn't make any sense. Why is there a t there? This is a really good question nobody's asking, but if I was a student in this class, I would be asking, why the shit is there a t there? That would bother me. And I try to talk about it a little bit. Whoa. Oh, wow. Ralphie and Potsy, I love it. So in general, if I have this, so why, now think about this, why would this, so this is g of x. This other formulation would make no sense. And I know this is a little beyond your question, but this is important. This is a point about the idea. So think about it. What is it for this function? What is another name for this function? This is the what function. It's finding the what for f. What's it finding? When we first gave this function, I told you what it was. In fact, what does an integral tell you? Area. Beautiful. This is the area function. Under what from what to what? Under f from a to x. So there's no way in hell this could be x also, or else it's moving around too. I'm given a function. It's there. I can't have a variable of this guy in this guy also. It doesn't make any sense. So this makes zero sense. So the variable can only be there. It's starting at A up to what point, and it's the area I've accumulated up to that point. The inside variable has to be its own thing. The function's just sitting there. It's not changing, it's not moving, it's just sitting there. And I'm finding the area. The only place the true variable could be for this function is right there. Now, when do you replace this with that? After you've taken a derivative. I like it. And once you take the derivative, the integral's gone. They cancel. Just like squaring a square root. Right? They cancel each other. So if you put the x in, that tells me you must be taking the derivative. This really shouldn't be here. Or you're setting up something that doesn't make any sense. Yeah. Does that? Okay. So this is how, now you answer, like you ask follow-up questions, and then we have a conversation. So, yes?
I was just going to say, so would that mean that the final answer would just be like this equation that we had here, just with an x in it? Instead of a t?
Almost. There's one little thing, one little tiny thing, and then I'll come back to this again, because this general idea is important, but it is not immediately obvious, which is when you ask questions. The one little thing about this, so if I do have this guy's derivative is just this. There is one little difference that we've talked about, showed up in the homework. What is the one little difference with the problem you have? Something's not the same that you have to take care of. If you look at if you look at that last problem, what's different? Decent number of you guys notice this. is it in the right form for this rule to hold? Why is it not in the right form? What's different?
The variable has to be on the top.
Yeah, beautiful. So I gave it to you like this. So the first thing you have to do is,
Switch it and make it negative.
beautiful, I like it. That's the one little tiny thing. Then you take the derivative, and taking the derivative of an integral should be easy, because they should just kill each other. Yeah, so now, then you can take then it would just be that, but with a negative in front. I like it, I like it. Too many people are trying to do U sub and all that. No, why would you? So if I was like, do this problem. If I said do this, and you start doing the inside, that's why these kill each other. You're done. I mean, so. Why would you start doing the integral if I'm asking you to unintegrate it, just to make up a word? Okay, so now let's come back to this idea. Take care of this. Ralphie, Potsy, Mrs. C. All right. So, let me ask you. If I give you a function, right, is it fundamentally changed if I do this instead? Right, if the function is x minus 2, is the picture changed, or is the idea changed if I call it f of t equals t minus 2? Are those different? No, they're not different at all. I like it. The only difference is just a choice we have to make. And since we normally like a function that we're looking at, if we can, we like to make the input x, because we're used to that. We'll make the input t if it's time, we'll make the input whatever. O if it's oranges or origins. But, so they give me so for this kind of problem, they give me a function. I set up a new function. So my new function, I want to, so if let's just make this a general function so I can have a more interesting picture. So if I have some function, and I want to know the area up to some point, but I don't want to set that point. I want to let that point be the true variable. So if I put a 3, it'll be the area from A to 3. Right? If I put a 4, it'll be the area from A to 4, and so forth. So I want that up to thing. I want that to be the variable. Stay with me now. You got to get this. I totally could have done this instead. Let me call this t. Let that be my variable. And let f stay with an x in it. Completely fine. But we don't like to have t there unless it's time. So the t is the dummy variable in this case. So instead of saying this is the t and this is its own thing, f of x is its own thing, just sitting there. The real variable is how far along it do I want to go. That's the only thing that should be changing, is that one thing. How far do I want to go? So back in the day, what they decided to do instead, they didn't like this. They said, no, let's put the x here, which means we'll put the dummy variable there instead. But if you put an x here also, it doesn't make any sense, because then somehow this is controlling how far you go and where you are. It doesn't make any sense. Or what value you're looking at, it doesn't make sense. This is what's given to me. This is the only thing that should be changing according to my area function. How far do I want to go? The inside can't be changing also.
I still don't understand why, because most of the examples, you essentially just change the inside function, or the f of t function, to x.
After I've done what?
Remains the same.
After I've done what? When do I change the inside to x? After you do what? So if I have this. When am I going to change the inside to x? After I've done what? Otherwise, it doesn't make any sense.
Do we have to take the antiderivative first?
Of course. So let's do this again. I've shown you this once before. This is really good to see, to really understand why this theorem is the way it is. Does this guy have an antiderivative? Yes. Can we figure it out knowing what we know? Hell no. Can I call it something? What do we normally call the integral of some function? If I don't know what it is, we call it big ass f, right? So let me call this integral big ass f. And I'm going to evaluate. So I've done the integral of this. I've done it. It's something. I don't know what it is because we don't know yet how to handle this shit. In Calc 2, you'll learn that's the very first thing you learn in Calc 2 is how to handle this. This is not very far away from what we know. It's sort of related to U sub, just one level up. But right now, we don't have a clue. Is everybody cool with me just saying the answer to this antiderivative is this? Just so I can work with the shit, right? And then I evaluate it from 2 to x, right? All right, let me stop right there. Is everybody with what I'm doing? What have I done? Not much. I don't know how to integrate this. Let me just call the answer, whatever the answer is. And there is an answer to this antiderivative. We just don't know enough right now to do it. And I am going to take a derivative of this shit. So it really doesn't matter. Because I'm going to undo what I'm going to do. But there is an integral to this. There's an antiderivative. There it is. And I'm evaluating it between these two things. Now here's exactly what I'm talking about. Right? What's the next step? What do I do with these? There's no way I can have this mean anything different than it always does. What do I do with this? Plug it in. Minus, plugged in it. You guys with me? Let me keep this prime thing on the outside here. Right? So this would be big ass f of x minus big ass f of 2. What is big ass f of 2 physically? I love that question because you're like, I don't know, a frog? No, but is it a function? Is it a constant? Isn't that a constant? If I put a 2 into this function, I'm going to get a constant. Am I not? Yes? Okay, I like it. So what's the derivative of this piece? What's the derivative of a constant? It's 0. Right? You guys with me? That's why this shit doesn't matter. That's why it's just a in the rule, because it don't matter what constant it is, because eventually it's going to just be a constant you kill. Doesn't matter. But what's the derivative of big ass f? Basically, it's the definition of this dumb thing, right? What's the derivative of big ass f? Little ass f, right? So what the fundamental theorem of calculus has said is, okay, this is just freaky. Why don't we just, I don't even know what that is, so why even write it? Look at the shortcut. When you take the derivative of this, it's the inside with an x stuck in. So the answer in this case is going to be, now that I've taken the derivative, I can put x in. Done.
That's exactly what I did. So I just don't understand.
You did this. Let me show you what you did, because I'm not sure you've got what you did right there in front of you. So what you did was this. Can you see what's wrong with that?
Oh, it is.
What's wrong with that? It goes against the very first part of what I was talking about. That makes no physical sense. You can't have a function where this is controlled and these are controlled. It doesn't make any sense. I have to have a set function and I'm going up to a certain place. The only place the variable should be is there. You don't plug x in until you have taken the derivative. If you have taken a derivative of an integral, what symbol should not be there? the integral symbol, because you've taken a derivative. It kills it. Okay, I like it. I like it. I like it.
And it shouldn't have the dx at the end?
No, it shouldn't. No. All this crap should go away.
Okay.
Yeah, because those go together. That's like the first. Now, the interesting about the integral symbol stuff, this is the first time we've seen a function notation where it's bookends. Y'all know, I know books have gone off the wayside and all that shit, but you know bookends, right? They hold up, there's this one I want to get that's got Yoda using the Force to hold the book up. Wow, right? Because I'm a complete geek. So bookends, it's the first bookend function we've ever seen. So you put something in between these two symbols to attack it. It's like a square root symbol, you put something inside of it. A sine symbol, you put something inside of it. An integral symbol, you put something between these two. That's neat. So yeah, you're right. It would go away because it's part of the integral symbol. Kick ass. This, by the way, is how classes work. We need conversation. You need to be able to ask questions. You need to be able to ask follow-up questions if you don't understand. My purpose is not to be a walking, talking book. My purpose is to go off of what you don't understand and figure out how to explain it. That's why I love this job. I try to figure out how to restate something, and then I know it even better myself then. I love that shit. So it's a little bit selfish, yes?
6.12, the areas of the curves. I just wanted to be able to understand whether we should take the absolute value of the answer, because I don't have a negative answer.
Oh, so anytime. So what was it I really focused on? Well, maybe not a crazy amount, but a decent amount about area between curves. What's a huge deal to figure out first? This is not the kind of problem you're talking about, because this kind of problem would not have the issue you're talking about. But let me just start here. So let me draw these in different colors. Oh, you can do better. Get out of there. Go away, you. Okay. When I'm going to go set up the integral to find the area between these two, how do I know how to set up the inside of it? What's the most important thing? Which function is on top? Because then it's going to be the top one minus the bottom one, right? How tall is some arbitrary rectangle in here? It's the top minus the bottom. If you have a problem where they tell you from 1 to 5 or something, and which function is on top changes in the middle of that shit, well, I just didn't do it right, did I? You could do it, Jeff. There you go, buddy. Right? So somewhere it changes. Which function's on top changes. I'm almost certain that must be what's happening in the problem you were dealing with. So they use absolute values. That is stupid. That is so stupid. I don't know if I've railed against absolute values with you guys at all. Absolute values are the most evil invention we've ever created because it's actually a piecewise function and it hides what it's doing. But those symbols have higher order meaning. That's why I'm like, don't get rid of them. So don't worry about all that shit. I'm sorry. But so often when they use absolute values, you don't need to. So let's say this is 1 to 5 and these two meet at 4. Looks good, Jeff. Can anybody figure out? First question that's going to give away the answer really is how many integrals do I need to set up? 2, because why? There's one integral where the green one's on top, and there's another integral where the black one's on top. So the first integral is going to go from 1 to 4 with green function minus black function, blah, 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 right? Yeah, this is good, Jeff. And then from 4 to 5, get out of there, plus 4 to 5 with that turned around. Does that make sense? Is that sort of related to what you're asking? If you look at some of the examples, they use absolute values. You really don't have to. Sort of like I explained how they have that picture like this and they use absolute values to figure out the total distance traveled. You don't have to. You don't have to use absolute values. It's like adding an extra step, to be honest. It's actually writing it kind of lazy instead of just going, where are things changing? How do I change it at that place? Absolute value is sort of like, I'll worry about this later.
So if you get a negative answer, it's a wrong answer.
Totally. For areas between curves, It has to be an actual physical area. So even if everything was happening down here, the area between these two is positive. It just is.
That also applies if it's half above the x-axis.
It doesn't matter. Now, I want you to realize what I'm saying right now. The x-axis doesn't matter worth shit. What I'm dealing with, areas between curves. It doesn't matter. If I drew that whole thing, if I put here, you put the x-axis here, you do it the same way. Same exact way. Because this minus this is going to be positive throughout, and this minus, and then the other way around is going to be positive throughout. I like it. No absolute value required. These are the kind of questions I need, because I disagree with the book in some places as to how the best way to look at something is. They give a great way to think about it, if it makes sense to you. I give another way to think about it. Oh yeah, so if I have the integral of some function, if here's f of x, the integral between those two are going to, the answer is going to be negative. I like it. Now watch this. Now, if the question said, so if I just said find the integral from a to b f of x, and that is what f of x is. If I just ask you this, get out of there. If I just ask you this question, the answer is going to be negative for damn sure, right? And physically that's fine because it could mean loss of money. This is the total amount of money I lost between A and B. So the answer, of course, has got to come out negative. Now watch, this is kind of nifty. You ready? If I ask you, find the area between y equals 0 and f of x from A to B, that is a different question. What's the top function? What's the top function? Y equals 0. So 0 minus f of x. So now I'm going to integrate. This problem would say integrate from a to b. 0 minus f of x. See that negative times that is going to make the answer come out positive. Because then in that case, the problem wants the answer to be a physical area. So is that something that you have to consider in real life? If it's got to be shit, yes. Right? It's going to be the same numerical value. You guys with me? If that's 5, if that's negative 5, this is going to be 5. So on one level, it doesn't matter. You're the human. You know if it's supposed to be negative or not. Maybe, but it is something to consider. So the area between two curves, inherently that question is going to come out positive, because that means a physical area. The integral of a function can come out negative. And why does that also make physical sense? Because we're not always talking about physical areas. We're talking about loss of money, how much heat flowed out of a reservoir, things like that. How much oxygen has escaped through the hole in my space shuttle, whatever, right? So it could be negative because it represents loss of. Maybe. I like it. Does that start to make some sense? So that's why we have the option to have a way to make the answer positive. I really want some of you guys to realize on some level, it doesn't matter where shit, the number's going to be the same, really. What you got to be careful about is when you're dealing between two functions and they cross somewhere, that should naturally sort of make sense that something's going to shift there. It's going to break it up into two integrals then, because something fundamentally changed. And Riyam, I never checked. It seemed like that was what was going on in that problem, or no? Yes, okay.
Yeah, thank you.
Sure.
One of the homework questions, I wanted to get asked to do Theorem and Son using a calculator, so I can apply.
Oh, yeah. Sorry. Don't worry about that, unless you want to. I wasn't really... Huh? No, and I'm not going to. I don't want to. You might pick up that I'm not the biggest calculator user. So when I was picking homework problems, sometimes I'll miss one that wants you to do something that I'm not going to make a part of this course. I think the one you're talking about is like finding the sum, using the sum stuff in your calculator, right? The sequence stuff.
It says use the Riemann sum, like or find the Riemann sum of right-hand points on your calculator for n5 and 10.
Oh, yeah. So there's a way to set up that expression using a sequence operation on your calculator, and then you can ask it to sum the sequence from something to something. And at that point, it's kind of like, why not just integrate it if you're going to use your calculator to do all the work for you? Why not just go ahead and integrate? Right? So I'd much rather have completely by hand, and then we transition to, here's how you can make the calculator do that same thing and get the exact answer. But there is a way. And if you go to Calc 2, you might have a teacher that wants you to use some of that, but they're going to assume you've never seen it before. Yeah, so if you get one of those teachers, you'll be able to do it. If you get me, you won't have to do it still.
So just cross that out.
Yeah, don't worry about that problem. That's fine. Yeah, I like it. I didn't do that to trick you. I just missed it. Yeah.
I had a question on Newton's method.
Yes, Newton's method.
Yeah, if you can just do a sample problem.
Yeah, let's do it. So I decided to be, although I don't think I put a problem on this practice test. I think I did tell you there would be a Newton's method. The last time I taught, I didn't have the Newton's method on this test, so I don't think there was one on there. So what I've decided is I'm going to go ahead and give you the expression, the form of Newton's method. But does anybody remember the algorithm for Newton's method?
Yeah, it's x n plus 1, or is it just n? Okay, minus f of x over derivative of x. Or, yeah.
Yeah, cool. I like it. I like it. So I'll give you this. Your work will be setting that up either for the first iteration or even better with a little ANS in it to show me what you're plugging in the calculator. This is one of the few times, since it's just freaking multiplying, dividing, subtracting, I mean, I don't need to see you doing that shit. We can just make the calculator do it, and it's nice to be able to function, to program this in the calculator so we can just do it over and over and over again. So we did that in class several times. We'll do it again right now. So let's make up a function. Yikes. Let's do this. Let's do it this way, because I'm probably going to give you a problem like this. What you got, Jeff? Yeah, okay. You can do that. Let's do this. Cosine x equals x squared. I like it. That's all right. I'm used to paparazzi. I'm my own paparazzi. I am going to ask you to sketch the problem to get your first guess. Some of you will just put that in and get your calculator to give you the answer. But the whole point of this is we're discovering the algorithm behind what the calculator does. So if your first guess is a little too on the nose, I'm like, well, shit, you're giving that shit away. So at least, the answer is 1.7846. Maybe make your first guess 1.5. Be a little smart about adjusting what you're seeing. I'd much rather you actually get this from just a rough sketch. Your first guess is not supposed to be perfect. So how would I do that? I wouldn't subtract x squared and then try to rough sketch that, because I don't know what cosine x minus x squared looks like. I do know what cosine x looks like, and I do know what x squared looks like. So I would sketch them on top of each other and see where they meet, because that's what this is fundamentally saying. Where does this graph equal that graph? Where do they meet? So cosine, of course, starts where? 1. I like it. And where does it hit the x-axis? Pi over 2. Yeah. And of course, my x squared starts at 0, 0. Pi over 2, so 1 would be about right here, maybe, roughly. Pi over 2 is 1.57, maybe 1 is right there. You guys kind of with me? And this is not perfect, but that's beautiful. It's not supposed to be perfect. So if I do this, it looks like, so here's 1, this is 1, so my x squared is going to go through that point. So what would be my guess? Let's just focus on this guy. Maybe I'll say the positive. I'm going to ask you to find one solution. I'm not going to ask you to do this for multiple solutions. Okay, stay with me now. What would be a good first guess then? That's where they meet for the positive side. That's a little below. What's a good first guess then? What's that x value?
0.75.
Okay, sure. Why not? So we'll say, since you're the only one saying anything. Huh?
I said or 1, right?
Yeah, or 0.9. Let's do 0.9. Okay, I like it. So I'm probably going to have a problem. I'll just tell you this right now, where I have you get your own first guess and do it, and then I'm going to give you a number to start with and you do it again. And the reason I'm doing that is that number might be a problem spot. And in the homework, you had to identify possible problem spots and explain why they were problems. So this should not be a big deal. So how do I find, let's just set up x2. I know what x1 is. So what's x2 going to be?
Plug in 0.9.
Yeah,
for all
so
the-
x2 is the one before it, 0.9, minus f of 0.9. Now what's my f that I'm dealing with? We got to go back. Now I do what with this to figure out what my f is? Because what is Newton's method solving? It is finding the x-intercept of a function. So what do I have to do here to figure out what the f of x is that what the f of x is? What do I do? You've all done the homework, so you should know. What do I do to figure out f of x? Yeah, just subtract x squared, for example. You could subtract either one, but let's subtract x squared. There's my f of x. Because this Newton's method is developed to find x-intercepts of things. When I draw my picture, I'm not going to do this because I don't know what the shit that looks like. Right? I do know what that looks like. I do know what that looks like. So that's how I draw my picture. But then I suck that sucker over so I have an actual function to look at. So this will be minus cosine of 0.9 minus 0.9 squared. Right? Just plug a 0.9 into f. So if f of x is this, what's f prime?
Sin x minus 2. Is it negative sin x? Oh yeah, negative sin x.
Negative sine x minus 2x. So this on the bottom will be negative sine 0.9 minus twice 0.9. All right, let's do this up here. I should have awoken you guys earlier. Oh, wait. I don't think that's satisfying. There it is. All right, just to remind you how to set this sucker up. Oh shit, did I hit the right button? No. I think that's the one I want, maybe. Yes. So far away. Okay. Wow. So now I can do, all right. So just to get x2 by itself, I could do 0.9 minus, where am I at? Cosine 0.9 minus 0.9 squared. Of course, some of you guys, you've got to be careful with your parentheses, right? Garbage in, garbage out. Your calculator knows order operations, which is almost bad for you. Divided by negative sign 0.9 minus 2 times 0.9. Yeah, I like it. Make sure everybody's okay up here. Yeah. So then it becomes 0.827. Now, let's do that all again. Yes?
I was just wondering, where did you enter that in? What's the menu function that you use to enter that in?
Enter what in?
Or is that just your normal? Just
That's
like,
normal.
Just your regular menu?
Oh,
Okay.
this is normal. I didn't do anything weird. All right. Now, let's start over again. Let's see if you guys remember how to. I'm going to redo this, but I'm going to set up the algorithm to capture this. And then I'll show you exactly what I need. You can either write that down for me and then just write the next few iterations out. That would be showing me work. Or you can write down the thing with the A and S in it. So what I've got to do first is to write 0.9 enter. Why did I do that? What's the idea of A N S? You have a little button, A N S. This guy. What's the idea with that?
Chase the answer and
What's in that memory spot right now?
the last answer.
0.9. If I wouldn't have put that in there, what would have been in there? 0.827. Right? No?
Wait a minute, what?
ANS holds in memory the last number that showed up on the screen.
So why not the... Oh, I see what you're saying.
I'm trying to start over so we can...
making it-
I want to make sure you can see this number coming out, even if I set it up with ANS instead of 0.9. So now to do this, I'm going to put answer in place of 0.9. Because then I can make it do it over and over and over. Because the minute I hit the enter button, it's going to be 0.827, blah, 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 blah. And now that's in ANS. And then I hit enter, so it's re-plugging that in. That's the whole idea of Newton's method, is make a guess, get a better guess. Use that guess to get a better guess. Use that guess to get a better guess. Every time I hit enter, it's re-evaluating using the last best guess to give a better guess. Is your hope. If you pick a bad first guess, it's going to go to shit. So now instead of 0.9, I'm going to put answer minus cosine answer minus answer square divided by negative sign answer. Where'd you go? Minus 2 times answer. Yeah. Kabam. Let's see if I can do that right. Yay. And then if I hit enter, now it's going to reevaluate. Every time you hit enter again, it reevaluates the last thing you typed. But now what is this? X2. So if I hit enter, it's going to give me X3. If I hit enter, it's going to give me X4. And eventually I get to a point where they don't change at all, and that's the best resolution that the calculator can give for this problem. The answer actually has an infinite number of places, but that's where the calculator just goes, I'm tired. Maybe. Is that all right? Is that? And just to kind of show you, let's do this. You ready? So if I put, let's let the calculator do all this stuff behind the scenes in the magic black box here. That is the calculator. So if I put into y, where is it? Here it is. Cosine x minus x squared, because that's the function we're dealing with, right? I can't remember if I did weird things with this. Let's see. Here we go. There's the cosine x minus x squared. So I'm going to try to find this. Let me zoom in so we can really see what's going on. I like the zoom box. I was going to say, and I can't lie, but I won't say that. Okay, enter. I'm just going to zoom in so we can really see what the shit's going on. Let me make that a little wider. So I'm going to try to find the intercept right here. And when I tell the calculator to find it, it is doing this. Modified a bit. TI guards their modified algorithm. think I told you I tried to find out what it was, and they're like, you might be from HP. Screw you. All right, whatever. So how do I find that? Anybody remember how to find that? Let me turn down the brightness on this thing. There it is. Anybody remember how to find that answer, that X-Intercept? Anybody remember what another name for the X-Intercept is? Second calc. What makes sense here? What am I trying to find? No? Zero. So I don't have two functions, and I'm trying to find the intersect of those two functions. I'm trying to find the zero of this cosine x minus x squared. So look what it does. Why does it make sense what it does now that we know some more about this? When does this thing go to shit? When it takes me, when I have a slope that's like, takes me way far away. If you've done the homework, you know what I'm talking about. That just kills it. So what's the first thing the calculator does? What's the first modification they made? Give me somewhere to live in. So that if one of my iterations comes way out here, I know to go back and start over. The calculator does. Does it make sense? So it says, tell me where the answer is between. So if I go outside of there, I'll start over again. But it does it stupid fast. Right? Obviously, it's a calculator. So it asks me for a left bound of the answer. So I just go a little left of the answer, right bound for the answer, go a little right for the answer. Then my guess, this is x1. My guess is x1. Obviously, the better my guess is, the quicker it's going to find it. And sometimes the better the answer is, because sometimes it stops and it gives you an answer that's not really quite right. So let's see. I can't really see. You look over there, 0.8241, blah, 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 blah. I'm pretty sure that's what we just got, right? I should have wrote that down, yeah.
When you, after you plug in your original answer equation with the 0.9,
Yeah.
You know, you plug everything in, how do you do it so you're getting the next answer, the next answer, and the next answer?
So what I did it once just to show you what the number was, so you'll buy in more to this. So what I do is I put x1 in and hit enter.
Mm-hmm.
That feels weird, but what that does is it preps the ANS. It preps it. It has 0.9 in it now. So now when I tell it to do all this, it is first doing that with 0.9.
Mm-hmm.
Then I'm going to do it all over again with what I just got, because that's the idea behind
Right,
this.
but are you re-entering?
No. So let me do this again. All right. So there's the whole thing, right? So I did 0.9. So now 0.9 is in ANS.
Mm-hmm.
Now watch it. Hit enter,
Mm-hmm.
enter, enter. Because whenever I hit enter, it reevaluates the last thing it told you to evaluate. Or you told it to evaluate.
Mm.
If your calculator's giving you commands, you probably should see somebody. Now watch this. Let's start off with, these are nice functions. So I mean, let's see how far away I can get. So if I put 9 in, that is horrendous first guess, right? 9 is way the flip off. But it will eventually get there. It just takes a little longer, right? So if the functions are really nice, I could be way far away. The freakier the functions get, the closer my first guess has to be. Now, if I go too far away towards the other answer, if I put 0 in, what would happen here? Let's see. Obviously, right? Because what's true at 0? Go back to the graph. What's true at 0? What's true at 0? What's true at 0? What's true at 0? That flips this thing up crazy. What's true at 0? You're like,
I don't understand.
say it louder.
What you're asking.
What is true at x equals 0 that would make this process freak out? Because did you just notice it freaked out? Did everybody notice that? Let me do it again. So if I put 0 in as my first guess, and I get here, that is a freak out. Divide by 0. Okay, look at the algorithm. What's the thing that I'm dividing by? What am I dividing by in the algorithm? Slope. What's true? Let me ask this again. What is true at 0 for this function? Slope is 0. So of course it's going to have a division by 0, another thing you should have seen in the homework. So that's one way to make this thing freak out, is to have some point. It doesn't have to be your first guess. It could be your second guess, and there was a problem they had to deal with that. Here's your first guess. It goes here. It's flat. Oh, shit. The whole thing dies. The second iteration dies. Because you can't define by 0. All right. What if I put in like, now watch this. Let me see. Well, now I'm just playing around because I'm curious. If I put 0.1 in, yeah, okay, it didn't go that far away. It kind of makes sense. If I put 0.1 in, that's close to 0. So the closer I get to 0, the further it should take it away. And hopefully, so if I put 0.001 in, that is really close to a 0 slope. So it should take, the second guess should be pretty decently far away. Positive, because now I'm like here, right? 0, it's 0 slope. Here it's a little, so it's going to say, way the shit over there. Let's see how far away I go. Well, you didn't put it in the chat. That was anticlimactic. Here we go. Yeah, there you go. So again, let me show you. So if I put 0.001 in, that's almost flat there. It's just barely a negative slope. So it's going to take it way the hell out to 333. So really, technically what's happening, if I put 0 in, it takes the next guess to infinity. So that's why it freaks out. It's like, I can't handle that shit. I don't have that kind of time to get out to infinity. Okay, maybe not.
I wish I would have known that all you have to do is press enter.
Oh man, if I would have just said that. Like it did. Okay. We did a couple of those before, and that's exactly what we did. I like it. Okay. Is that all right? You guys, is that all right for Newton's method? You want to do another one, or you got a different topic? Is everybody here right now that, does everybody have a practice test? I think everybody should have one, right? Okay. I'll give you the answer key here in a minute. Yes?
I'm completely not clear on discs, washers.
Okay, good.
And
That's what I wanted to focus on. A little bit more structure to it. So, what we're going to do, what I want to try to do, is everything I've said before, but in a different organization. Now that we've talked about discs and we've talked about shells, hopefully everybody understands that washers is not a third method. It's just 2 discs subtracted. So I hate when they give it a name and it makes it sound like it's a brand new thing. Sort of like that linear approximation is really just a freaking tangent line. But, so let's talk about discs first. The most important thing to know about discs in a nuts and bolts doing a problem idea, not a conceptual idea. It's related to a conceptual idea. If I want to take a function and rotate it around the x-axis, my integral has to have what here for discs? Sorry. Oh yeah, thank you. I need a TA to move my camera around. Yeah, that would be great. That wouldn't freak me out. The AI would take over the world. I am done following you. What has to be here for disks if I'm rotating around the x-axis? What has to be here?
is it dx?
Beautiful. That is the most important step in any of these problems, to be honest. Now, you also have to understand how to put them together and the idea behind them. Of course, those are important. But in the nuts and bolts of working a problem out, that is huge.
Just for discs.
Disks. Shells, the fundamental reason that shells are able to handle most of the ones that disks cannot is because if for shells, what would this be? If I have a function and I want to rotate it about, how do I want to do this? Yeah, sure. If I have a function and I want to rotate it around the x-axis, what would shells do? Shells would say this is integral dy. So on a purely lame-ass level of, what do I put that gets this started? That's it. Now, why do I say lame-ass? Because you should understand why this is true. Then it's easier to remember. So with disks, I locate my circles along the axis I'm rotating around. Let me say that again. Because the idea of disk is almost too nice. You just have all these circular slices. Why is every slice going to be circular? Because I'm taking something and I'm rotating it. So of course every slice will be circular. So how do I get the volume of the whole thing then? Add up all these circle areas. On some level it's got to be almost too nice to believe. It's like, no, Jeff, it can't just be that. So whatever axis I'm rotating around, I locate my circles on that axis. For shells, this is going to be a little bit freaky with this picture, but oh well. What I do for shells is I locate the rectangle that I'm going to rotate along the axis that's perpendicular to what I'm rotating around. Because if I had a rectangle like this and I rotate it around the x-axis, I make a shell. Right? Take a rectangle, rotate it. Let me pick that up and show you that's a shell, right? That's a big pipe. And if I have a closer one, it's going to be a tighter pipe, or longer but tighter. Can you guys see they have a lot of nice illustrations in the book? You can do them definitely nicer than mine. Okay. That is the most important step. So how do you determine if you want to use disks or shells? Well, if you have a problem where you've got a function that is a function of x, and you're rotating around the x-axis, you probably don't want to do shells. Because what has to be in here, if it's dy, what has to be in here? A function of y. So the function I'm dealing with is something like that, and I'm rotating around the x-axis. I can plug that whole thing in there. It's dx for disks, right? It's dx for disks. So I can plug that whole thing in there. Everything's great. It would be pi times that thing squared. That's getting more into the details now, but if I wanted to use shells, that's insane. Can you solve this for x? If these two weren't, if that wasn't there,